Hello viewers, in today's session we are going to discuss another important problem from integration, and here we have to evaluate this integral that is from 0 to infinity, and we have x raised to 5 divided by 1 plus x cube raised to 5 over 2 dx. And here we are going to make use of the concept of beta and gamma functions to evaluate this integral. And before applying the concept of beta and gamma functions, let us first make use of the method of substitution to convert this integral into a beta function, that is beta m comma n is given by the integral that is 0 to infinity, and we have t raised to m minus 1 divided by 1 plus t raised to m plus n dt. So by a method of substitution, we'll first convert this integral into the beta function. So now let us first substitute t is equal to x cube, right? So that this term becomes 1 plus t raised to 5 over 2. So we'll take t is equal to x cube, and this implies that x is t raised to 1 over 3. So let us differentiate x with respect to t. So we have dx over dt is d by dt of t raised to 1 over 3, and making use of the power rule, we have nt and n minus 1, right? So here the value of n is 1 over 3, so we have the derivative of t raised to 1 over 3 with respect to t as 1 over 3 t raised to 1 over 3 minus 1. So this is 1 over 3 t raised to 1 minus 3 over 3 1 over 3 t raised to minus 2 over 3. So now dx over dt is equal to this expression. So now we can write dx is equal to 1 over 3 t raised to minus 2 over 3 and dt. So now let us change the limits accordingly. So here x varies from 0 to infinity, right? So when x is 0, 0 is the lower limit. The value of t can be obtained from this relation. So we have 0 cube, that is 0, and when x tends to infinity, that is the upper limit, then t also tends to infinity due to this result, right? So now let us write this integral I in terms of t. So we can now write 0 to infinity, and then we have x raised to 5, x is t raised to 1 over 3, so we have t raised to 1 over 3, and here we have 5. For dx, we can now write 1 over 3 t raised to minus 2 over 3 dt, and in the denominator we can write 1 plus t raised to 5 over 2. So now let us arrange the terms here, and we can simplify. So we can take 1 over 3 outside the integral. We have 0 to infinity. Then here we have t raised to 5 over 3, and here we have t raised to minus 2 over 3, and here we have 1 plus t raised to 5 over 2 and dt. So now we can write I is equal to 1 over 3 0 to infinity, and here we can apply the laws of exponents. So here the base is same, so we can add the powers. So we have 5 over 3 plus minus 2 over 3, that is 5 minus 2 over 3, that is 3 over 3, and that is t raised to 1, right? So in the numerator we have t raised to 1, and here we have 1 plus t raised to 5 over 2 dt. So now let us compare this integral with this one. right? So here we have 0 to infinity, here we have 0 to infinity, and t raised to 1. Here we have t raised to m minus 1, and here we have 1 plus t raised to 5 by 2, and here we have 1 plus t raised to m plus n. So let us find out the values of m and n in order to express this integral in this form. So we can now compare both these integrals. So we have m minus 1 is equal to, so we have m minus 1 equal to 1, and then m plus n is equal to 5 over 2. So let us solve this equation. So we have m is equal to 1 plus 1, taking minus 1 to the right hand side. So we have 2, and then taking m is equal to 2 in this equation, we have 2 plus n is equal to 5 over 2. So n is 5 over 2 minus 2, that is 5 over 2. This is 4, and 5 minus 4 is 1. So we have 1 over 2. So now we can write this integral I as 1 over 3, 0 to infinity, and t raised to 1. So 1 can be written as m minus 1. So m is 2, so we can write 2 minus 1, and here we have dt, and 1 plus t raised to 5 over 2. So 5 over 2 is m plus n. M is 2, and n is given by half, right? So now this integral is exactly of this form. So now the value of m is 2, and the value of n is half. So this is our beta function. So we have 1 over 3 times the beta function m comma n. M is 2 and n is half. So let us now calculate the value of this beta function with the help of this important relation between beta function and gamma function. So beta function is equal to gamma m times gamma n divided by gamma m plus n. So here we have 1 over 3, and then we can now write gamma 2. Then we have gamma half, and in the denominator we can write gamma 2 plus half. So we can now write the value of I as 1 over 3, and gamma 2 is equal to 1, because here we can use this result, gamma n plus 1 is equal to n factorial, where n is some positive integer. So if we take n is equal to say 1, then here we have 1 plus 1 2. So gamma 2 is 1 factorial, that is simply 1, right? And here we have gamma half. So gamma half can be written as square root of pi. So here we have square root of pi, and in the denominator we have gamma of 5 over 2. So now let us write the value of gamma of 5 over 2 with the help of this relation, that is gamma n plus 1 is n times gamma n. So here gamma 5 over 2 can be written as 3 by 2 plus 1. We can split 5 over 2 as 3 by 2 plus 1. So now our n is 3 by 2. So taking n is equal to 3 by 2 in this relation, we have 3 by 2 gamma 3 by 2. And further we can split 3 by 2 as half plus 1. So now we have 3 by 2 half times gamma half. So again applying this result to this expression. So now we have 3 over 4 gamma half is square root of pi. So substituting the value of gamma 5 over 2 as 3 by 4 times square root of pi, we can now write the value of I as 1 over 3. This is root pi, and here we have 3 by 4 times square root of pi. So these two terms get cancelled and we have 1 over 3 times 4 over 3. So we'll take the reciprocal of 3 by 4. So here we have 4 over 9. So viewers, the value of this integral is equal to 4 divided by 9. Hello viewers, in today's session we are going to discuss another important application of beta and gamma functions to solve this given integral. So here we have to evaluate this definite integral that is from 0 to 1, and the integrand is square root of 1 minus x raised to 4, and here we have dx, right? So let us see how easily we can solve this integral using some important results from beta and gamma functions, right? So let us start and let us first call this integral as I, right? And here let us briefly see the important results from beta and gamma functions which are going to be used while evaluating this integral. So here we are going to make use of the definition of beta integral, which is also known as beta function or Euler's integral of first kind, right? So here the beta function is defined as beta m comma n, and this is given by the integral 0 to 1, and here we have t raised to m minus 1 and 1 minus t raised to n minus 1 and dt. And remember, m and n are greater than 0, right? So here by making use of the method of substitution, we'll first convert this integral into this one, right? And then we'll apply the relationship between beta function and gamma function. So the beta function and gamma function are related by this expression, that is beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So apart from these two important results, we'll also make use of the famous Euler's reflection formula, that is gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? So these three important results are to be used while solving this integral, right? So let us first convert this integral into the beta function by making this substitution, that is x raised to 4 can be taken as equal to t. So here we are introducing the variable t, right? So we can now write x is equal to t raised to 1 over 4. Now let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 by 4. Now to get the derivative of t raised to 1 over 4, let us make use of the power rule for differentiation, that is the derivative of t raised to n with respect to t is n times t raised to n minus 1. So here our n is 1 over 4. So we have 1 over 4 t raised to 1 by 4 minus 1, that is 1 over 4 t raised to 1 minus 4 over 4, that is 1 over 4 t raised to minus 3 by 4. So 1 minus 4 is minus 3, right? So now let us write dx is equal to 1 over 4 t raised to minus 3 by 4, and here we have dt. Okay, so now here when we make use of the substitution method, we have to change the limits accordingly. So here we can see that the limits of integration vary from 0 to 1. So the lower limit is 0, the upper limit is 1. So when x is equal to 0, the value of t can be calculated from this relation. So t is 0 raised to 4, that is simply 0. And when x is 1, then t is 1 raised to 4, that is simply 1. So when x goes from 0 to 1, t also changes from 0 to 1, right? So the limits remains the same. So we can now write this integral I in terms of t, right? So we can now write t is equal to 0 to t is equal to 1, and we have square root of 1 minus t. For x raised to 4, we'll write t, and for dx we can write 1 over 4 t raised to minus 3 by 4, and here we have dt, right? So now this integral is reduced to this one by the method of substitution. So let us rearrange the terms so that we can form this type of integral, right? So we can take 1 by 4 outside the integral, and we have 0 to 1, and here we can write t raised to minus 3 by 4, and square root of 1 minus t can be written as 1 minus t raised to half, and here we have dt, right? Okay, now here let us compare this integral with this one. Here we have 0 to 1, and here we have t raised to m minus 1. Here we have t raised to minus 3 over 4. Here we have 1 minus t. Here also we have 1 minus t, but here the exponent is n minus 1. Here we have half. So let us find out the values of m and n. So m minus 1 can be equated to minus 3 by 4, and n minus 1 can be written as half. So solving these two equations for m and n, from here we can write m is equal to minus 3 by 4 plus 1, that is minus 3 plus 4 over 4, that is 1 over 4. From here we can write n is equal to half plus 1, that is 1 plus 2 over 2, that is 3 over 2, right? So now we can write 1 over 4, then we have 0 to 1, and t raised to minus 3 over 4, and here minus 3 over 4 is m minus 1. M is 1 over 4, so this exponent can be written as 1 by 4 minus 1, and then we have 1 minus t raised to half. So half is n minus 1. So n is 3 by 2, so here we have 3 by 2 minus 1, right? So we have now expressed this integral uh, in terms of, or in the form of the beta function, right? And here we have the additional factor 1 over 4. So now we can write 1 over 4, and m is 1 by 4 and n is 3 by 2. So we can now write beta 1 by 4 comma here we have 3 by 2, right? So now the value of this integral is given by this expression, and let us calculate the value of this beta function using this result. So now we can write this integral I as 1 over 4. Then we have gamma 1 over 4, and then we have gamma 3 by 2, and in the denominator we have gamma 1 by 4 plus 3 by 2, right? Now 1 over 4 plus 3 by 2 can be written as, taking the LCM here, 4, then we have 1 plus 6, so this is 7 over 4. So now we can write this integral I as 1 over 4 gamma 1 over 4 times gamma 3 by 2 divided by gamma 7 over 4. Now let us write the values of gamma 3 by 2 and gamma 7 over 4, because here we are going to express this integral I in terms of gamma 1 over 4. So now we know an important relation, that is gamma n plus 1 is given by n times gamma n, right? So here in the list of these three important results, we can also add this one. So gamma n plus 1 is equal to n times gamma n. So gamma 3 by 2 can be written as gamma half plus 1, because we can split 3 by 2 as half plus 1. So our n is now half. So we can now write half times gamma half, and gamma half is equal to square root of pi. So we can now write half times square root of pi, right? Okay, now let us write the value of gamma 7 by 4. So we can now write gamma, and here 7 by 4, we can split this 7 by 4 as 3 by 4 plus 1, because 4 times 1 is 1, 4, 4 plus 3 is 7. So we can again make use of this result. So our n is 3 by 4. So here we have 3 by 4 times gamma 3 by 4, right? Okay, now let us make use of Euler's reflection formula, right? Because we have to express gamma 3 by 4 in terms of gamma 1 over 4, right? So here we can substitute n is equal to 1 by 4. So the Euler's reflection formula is gamma 1 minus n gamma n is equal to we can write pi over sine n pi. So let us substitute here for n 1 over 4. So gamma 1 minus 1 over 4, then we have gamma 1 over 4, then we have pi divided by sine pi over 4, because n is 1 over 4. Now sine pi by 4 is sine 45 degrees, and sine 45 degrees is equal to 1 over square root of 2. So we can now write here 1 over root 2. So taking square root of 2 to the numerator, we can now write pi times square root of 2. So now here we have gamma 1 minus 1 by 4. So this is gamma 3 by 4. And here we have gamma 1 over 4. And in the right hand side, we have pi times square root of 2. So now from this relation, we can now write the value of gamma 3 by 4. So we can now write gamma 3 by 4 is equal to pi root 2 divided by gamma 1 over 4. So now substituting the value of gamma 3 by 4 in this relation, we have here the value of gamma 7 by 4 as 3 by 4 times, then we have pi root 2 divided by gamma 1 over 4. So now we can rearrange the terms. So we have 3 pi root 2 divided by 4 times gamma 1 over 4. So now let us substitute the value of gamma 7 over 4 in this relation, and then we'll also substitute the value of gamma 3 by 2, that is half root pi. So now we can write I is equal to 1 over 4. Then we have gamma 1 over 4, and gamma 3 by 2 is half root pi. And then we have gamma 7 over 4 as 3 pi root 2 divided by 4. And then here we have gamma 1 over 4, right? So let us rearrange the terms. So we have 1 over 4, then we have gamma 1 over 4, then we have half root pi, and taking 4 times gamma 1 over 4 to the numerator, that is we can now write 4 times gamma 1 over 4, and here we have in the denominator, that is 3 pi root 2. So now here this 4 and this 4 get cancelled, and here we have gamma 1 over 4 times gamma 1 over 4. So we can now write gamma 1 over 4 square, and then here we have root pi, and in the denominator we have 2 times 3, that is 6, and we have 6 pi root 2. So now see, here we have pi raised to 1, right? And we can now write gamma 1 over 4 square, and then we have 6 root 2, and here we have root pi over pi, right? And using the laws of exponents, we can now write 1 over pi 1 minus half, right? And this is 1 over this is 1 minus half, that is simply pi raised to half, that is 1 over root pi. So we can now substitute the value of root pi over pi as 1 over root pi. So we can now write gamma 1 over 4 square, and then we have here 6 root pi times root 2. So now we can combine these two terms, because here we have square root, here also we have square root. So we can now write gamma 1 over 4 square, and then we have 6 times square root of 2 pi. So viewers, the value of this integral is square of gamma 1 over 4 divided by 6 times square root of 2 pi. So viewers, this is how by the application of beta and gamma functions, we can easily evaluate integrals of this kind. So the value of this integral I is gamma 1 by 4 square divided by 6 times square root of 2 pi. Hello viewers, in today's session we have another important and interesting problem from beta gamma functions, and here we are going to evaluate this integral that is from 0 to 2 x raised to 5 over 2 divided by square root of 2 minus x dx with the help of some concepts from beta and gamma functions, right? So let us start. So let us first take this integral as I, right? Now here what we will do, will first make use of the method of substitution, right? And by using the method of substitution, we'll convert this integral into this form, that is the beta function, that is beta m comma n is given by the integral 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So here we'll substitute x is equal to 2 times t, right? And using this substitution, we'll convert this integral into this form. So here x is equal to 2t, and t can be written as x over 2. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of 2t, and then we can write 2 times d by dt of t, and the derivative of t with respect to t is 1. So we have 2 times 1, that is equal to 2. So now we can write dx is equal to 2 dt. Okay, so now here we'll change the limits accordingly. So here the lower limit is 0 and the upper limit is 2. So when x is equal to 0, then the value of t can be obtained from this relation. So t is equal to 0 over 2, that is 0. And when we have x is equal to 2, then the value of t can be obtained from again from this relation. So we have 2 over 2, that is 1, right? So now let us write this integral in terms of d. So now we can write the integral I as 0 to 1, and here when x changes from 0 to 2, t goes from 0 to 1, and for x we can write 2t. So we have 2t raised to 5 over 2 divided by square root of 2 minus 2t. And here we have for dx we can write 2 dt. So let us now simplify this expression. So we can now distribute this power, that is 5 over 2 over 2 and t. So we have 2 raised to 5 over 2, t raised to 5 over 2. Here we have 2 raised to 1 and dt, and in the denominator we have square root of 2 times 1 minus t. So taking 2 common in the under the square root sign. So now we can write 0 to 1, we have 2 raised to 5 over 2 and t raised to 5 over 2, and here we have 2 raised to 1, and taking square root of 2 to the numerator, we can write 2 raised to minus half, and here square root of 1 minus t can also be taken to the numerator. So we can now write 1 minus t raised to minus half, and here we have dt. So now let us further simplify it. So here we can collect all these 2's. So we have 2 raised to 5 over 2, then we have plus 1, and then we have minus half, and here we have t raised to 5 over 2 and 1 minus t raised to minus half, and here we have dt. So now simplifying this term, so we have 2 raised to, here we have 5 over 2 minus half is 4 over 2, that is 2, and 2 plus 1 is 3. So we have 2 cube, that is equal to 8, right? And taking 8 outside the integral, we have 8 times 0 to 1 and t raised to 5 over 2 and 1 minus t raised to minus half and dt. So now let us write I is equal to 8 times the integral 0 to 1, and t raised to 5 over 2 can be written as 7 over 2 minus 1, because 7 over 2 minus 1 is equal to 7 minus 2 over 2, that is 5 over 2. And here we have 1 minus t raised to minus half, and minus half can be written as half minus 1, and here we have dt, because half minus 1 is equal to minus half, right? So now we can see that this integral is similar to this one, right? And here if we compare this integral with this one, then here we have 0 to 1, 0 to 1, and t raised to m minus 1. So here we have t raised to 7 over 2 minus 1. So comparing m is equal to 7 over 2, and here we have 1 minus t raised to half minus 1. So here we have 1 minus t raised to n minus 1. So comparing, again comparing, we can now write n is equal to half, right? So now we can write this integral I as 8 times the beta function, that is beta 7 over 2 comma half, right? So now we have to find out the value of this expression by using an important relationship between beta function and gamma function. So beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So here we can now write gamma 7 over 2, then gamma half, and then we have gamma 7 over 2 plus half, right? Okay, so now let us find out the value of gamma 7 over 2. Now gamma 7 over 2 can be written as gamma 5 over 2 plus 1. And here we'll again make use of an important result, that is gamma n plus 1 is given by n times gamma n. So here the value of n is 5 over 2. So we can now write 5 over 2 times gamma of 5 over 2. And again we can split 5 over 2 as 3 by 2 plus 1. So again applying this result to this one, so we have 5 over 2 times 3 by 2 and gamma 3 by 2. So let us further write gamma 3 over 2 as half plus 1. So we can now write 5 over 2 times 3 over 2 times half, and then we have gamma half. So here again we have used this result, right? So now this is 5 times 3 is 15, and here 2 times 2 times 2 is 8, and gamma half is given by square root of pi. So now in the denominator we have gamma 7 over 2 plus half. So we have 7 over 2 plus half is 7 plus 1 over 2. That is gamma 7 plus 1 is 8. 8 over 2, that is gamma 4. And gamma 4 is equal to 3 factorial, that is equal to 6, right? Because we know that gamma n plus 1 is equal to n factorial, where n is some positive integer. So now we can write the value of this integral I as 8 times gamma 7 over 2, which is 15 over 8, and here we have root pi, and gamma half is square root of pi, and divided by this expression, and this is equal to 6, right? So now this 8 and this 8 get cancelled, and we have 15 over 6. Root pi times root pi is pi, and again simplifying, this is 3 times 5, and 3 times 2 is 6. So we have 5 pi over 2, right? So viewers, the value of this integral I is 5 pi divided by 2.